Welcome to the third module of the course, and this module is on the very architectural components of a data warehouse. So I'm going to talk about uh, these particular components. So they are source systems, data staging area, presentation servers, data marts and supermarts, and data warehouse, and ODS, that is operational data store, and OLAP. And I'll also be talking about Kimball versus Inmon. So these are basically two kind of competing approaches to data warehousing. So I'll be giving you some idea about how they are different and which one is correct and which one is wrong. Not wrong, but which one is more suitable for you, right? So, and in today's presentation, like if you look at source systems, I think I've already given you some idea in the first two modules, like what we call a source system. Source systems are those systems which from which we take the data from to populate the data warehouse, and then once the data is selected, it goes into what is called as a data staging area, and where you have where you process the data, or I would say pre-process the data, or prepare the data for loading into the data warehouse. And this data warehouse is actually is a kind of a presentation server where data is now accessible to end user applications, whether it is OLAP or data mining or any kind of visualization that I want to do. And so I have given you already some idea about data staging area and presentation servers. So I'll not be going into too much details of that in today's lecture. So I'll possibly take them up in the second lecture of the second session of this particular module. So already I have given you idea about data staging area being analogous to the kitchen of a restaurant, and presentation servers are the sitting. They can be considered as a sitting area of a restaurant. So I'll give you more details as we go along. And today I'll be focusing mainly on data marts and operational data stores. Data warehouse, it is a kind of a repository, and OLAP also we'll be discussing. So there's a separate module on OLAP, right? But I have already given you some idea about what is OLAP and what kind of queries we run as part of on OLAP, right, or using OLAP. So these are the things that I have highlighted, or that I have outlined for or prepared for today's module. And let me start with the data marts. So, but before that, let me just reiterate the architecture which I have given you earlier. So these are this is the typical architecture. So I have given this to you earlier also. So just to reiterate, and so what we have is let me just remove the video. Yeah. So this is how it looks like. So what I'm going to do is I'm going to talk about two basic important things here. So one is this data marts, and you can see the arrows pointing downwards, right, from here. Okay, so this is a particular approach to data warehousing. And in another approach, what we do is we actually kind of integrate these data marts to form the data warehouse. So the arrows might flow this way also. So I'll talk about both the approaches. So I'm going to talk about data marts, and I'm also going to talk about ODS, which is not explicitly shown in this slide, and you will know the reason also. So the other part that I'm going to talk about is ODS, and why it is not shown in a typical data warehousing architecture, because it is optional, and only when you already have an operational data store, then only you kind of include it in the architecture. If it is not there and your objective is to build a data warehouse, then you don't worry about this ODS. So that's why this ODS is not explicitly visible in this architecture. So let me start with with the data marts. So what's the data mart, and advantages and disadvantages of data marts, and then issues with the development and management of data marts. So these are the things that we are going to talk about. So a data mart is a subset of a data warehouse that supports the requirements of a particular department or business process. So when I use the word subset, so it is not the mathematical subset of a data warehouse. So it is a subset in the sense that it caters to the needs of a particular department. Okay, so it is not a mathematical subset that you take out some data from the data warehouse and put it in a data mart, and so it becomes a subset. So we may be doing some kind of processing on the data to either put it in the data mart or take out from the data mart. So both ways, both kind of interactions, as I showed you in the previous slide. So if this is my data warehouse and these are my data marts, right? Say 2 data marts. So the flow can be from here to here, or also from data marts to data warehouse. So and while we do this, so there is always some kind of processing that is involved. Okay. So and this processing is typically involves aggregation. So I'll give you some idea about both aspects of this. So it is not a proper subset in the mathematical sense. Okay. So characteristics include, let me remove this one. Does not always contain detailed data, unlike data warehouses. More easily understood and navigated, because it is a kind of an abstraction in the sense that you are not burdened with all the data that is there in the warehouse. You suppose you are working on a particular department, so you will get to see only the data belonging to that particular department or that particular business process. And also another important thing about this is that, so in data mart the data is aggregated. So aggregated means the granularity. So I have already talked about granularity, I already discussed this. So what it means is that the granularity in the data mart is generally coarser than that in the data warehouse. So that's the difference. Okay, and data marts can be dependent or they can be independent. So let me now talk about the reasons or the kind of logic behind creating data marts. So these data marts work as a proof of concept for the data warehouse and can be developed quickly and less resource intensive than data warehouse. So I'll elaborate on each point. To give users access to data they need to analyze most often, and to improve query response time due to reduction in the volume of data to be accessed. Okay, so let me elaborate each point that is there on the slide. So it's a proof of concept. So what we do is that we select a business process or a department that is very important to you. Say for example, in any kind of business environment, sales is a very important business process, right? So you want to do some analysis on sales first. So if you were to prioritize, so you would say I would want to do something on sales first. Okay, so you say that, okay, I've selected this sales business process and I want to create a data mart for this. Okay, and why we do this? Because data warehouse, if you look at a data warehousing project, so it's a very resource intensive project, and resource intensive in the sense that it will take at least a couple of years to develop. It requires a lot of manpower, it requires a lot of money, and it requires a lot of planning. So Data warehouse projects are typically like 2 to 3 years. It takes somebody to develop a data warehouse. So it's a very long time. So if you approach your management saying that, okay, give me say $2 million or maybe more, and I need 20 persons, and I need 3 years time to develop a data warehouse, and you can use it once it is ready. So if you go with this kind of proposal, nobody is going to accept this proposal. So what we do is, so we say that, okay, give me a few months, like 4 to 5 months. Give me some $10,000, and I need 2 persons, and I'll give you a proof of concept. And once you are satisfied with the proof of concept, then probably you will be willing to fund the entire data warehousing project. So excuse me. So this particular concept, the data marts work as a proof of concept. So that is one of the most important reasons of creating data marts. Okay, and can be developed quickly and less resource intensive. So that point I've already clarified. And to give users access to data they need to analyze most often. So since data marts are business process specific or department specific, so I would not be burdened with data that belongs to other departments and other processes. And of course, the query response time would improve because you are dealing with less volumes of data. And now at this point, I would like to give you some idea about 2 pioneer workers, Ralph Kimball and W.H. Inmon, Bill Inmon as we call him popularly. So these two have given 2 different approaches, and I will not call them totally different approaches, but there are similarities and there are differences between their approaches. So let me just try to give you some idea about what they say. So Bill Inmon's paradigm. So data warehouse is one part of the overall business intelligence system. An enterprise has one data warehouse, and data marts source their information from the data warehouse. So this point you have to keep in mind. Data marts source their way or information from the data warehouse. So it's a flow from the data warehouse to data marts. Okay. In the data warehouse, information is stored in third normal form. Now, if you recall that earlier when we were talking about design aspects, so we said that we don't need to normalize. We don't need to have normalized structures in the data warehouse because there are hardly any updates. So Bill Inmon says that we want data in the third normal form. Whereas the Ralph Kimball's paradigm is slightly different. So data warehouse is the conglomerate. That means of all data marts within the enterprise, information is always stored in the dimensional model. Okay, so it does not talk about normalization and other things, and it says that data marts combine DM1, DM2, and DMN. So they contribute. When I integrate them, then I get a data warehouse. So you can see the contrast between these 2 paradigms. Okay, so more on this as we. So let me clear this. Okay. So Bill Inmon endorses a top-down design. So I'm sure all of you understand top-down and bottom-up design approaches. Ralph Kimball endorses a bottom-up design. Okay. So let me give you some more details. So independent data marts. So you can see now independent. I'll define them. Cannot comprise an effective EDW. Okay. Organizations must focus on building enterprise-wide data warehouses. Whereas Kimball says EDW effectively grows up around many of the several independent data marts, such as for sales, inventory, or marketing. So you can see again, this slide is there to highlight the difference in approaches, or the contrast in approaches between Inmon and Kimball. So okay, so and they are, from time to time they engage themselves in a kind of war of words. So this is an old statement, but I like this in the sense that they highlight the contrast between their approaches. So in December 1997, Kimball said that data warehouse is nothing more than the union of all data marts. Okay, and immediately after that, Inmon responded, so you can catch all the minnows. Minnows means small fish in the ocean and stack them together, and they still do not make a whale. And you can see it came within 10 days of Kimball's remark. So this is the kind of rivalry or competition that is there in the in the data warehousing community, right? So there are two broad groups. So data warehouse or data mart first. So what we should do, whether we should take the top-down approach, that is, we first build the data warehouse. So top-down means you first build the data warehouse, and then from here you carve out data marts. Or you first build the data marts and then integrate them to form a data warehouse. So this is what we need to worry about. So if you have done a course on software engineering, you are very well familiar with you'd be very well familiar with the advantages and disadvantages of top-down, and also the disadvantages and advantages of the bottom-up approach. So I'm just putting some general statements here. So advantages of top-down. So it's a truly corporate effort, an enterprise view of data. So that's the advantage. Inherently architected and not a union of disparate data marts. So that is another point. And central rules and control you can implement when you are using a top-down approach, and may be developed using the iterative approach, so which I think all of you would know. Disadvantages of top-down. So takes longer to build even with the iterative approach, and there is a high risk or exposure to failure because it's a long drawn project and very resource intensive. So we are not very sure about what we are doing, and needs high level of cross-functional skills because you are trying to take into account each department and each business process that is there, and high outlay without proof of concept. So till the time the data warehouse is designed and implemented and deployed, I would not have any clue about its usefulness, and difficult to sell this approach to senior management and sponsors. So this I have already talked about. Okay, so now advantages. So bottom up you can see is this approach. So this one I'll just put a box around it so that you know. So bottom up, faster and easier to implement of implementation of manageable pieces. So these data marts do not take very long to develop, and they are not very resource intensive, so you can develop them very quickly. And favorable ROI, so that means you can start using the data mart very quickly and possibly get the return on investment fast, and less risk of failure because you are not investing too much of your resources into this, and inherently incremental. So this approach is inherently incremental in the sense that you can schedule important data marts first. So you can say that I'll take up the most important business process in the organization and I'll develop a data mart for it, and allows project team to learn and grow. That means while you build the first data mart, right, so you will get some idea. When you go to the next data mart, you will have some idea about what you did and what where there is scope for improvement. So you, as you go, you learn. Okay, so that's the advantage. Then disadvantage. of bottom-up approach, each DM has its own narrow view of data, so you don't get the view of the enterprise. So that anyway is a problem with bottom-up. Permeates redundant data in every data mart. So unless you are very careful, you'll find that many data marts would have common data. So that is a problem, and it will be difficult to integrate if the overall requirements are not considered in the beginning. So so another very important point is that these data marts now work as islands of information, and if you have not kept the integrating framework in mind, so then it will become very difficult for you to integrate these data marts into the data warehouse. So one of the problems that you might face could be that different data marts are at different levels of granularity, and when you want to put them into the data warehouse, so you have to arrive at a common granularity, right? Okay, so that is one particular problem that you can face. So these are the disadvantages of the bottom-up approach. Kimball's approach is considered as a bottom-up approach, but he disagrees. So he says that it is not a bottom-up approach. So let us see what so Kimball encourages. So he says, so there is an article. So if you go to kimballuniversity.com, so you'll find lots of articles written by Kimball and his team on different aspects of data warehousing. So so KU, Kimball University. So I strongly recommend that all of you visit this site and go through some of the relevant documents or articles that has been written by his team. So Kimball encourages you to broaden your perspective both vertically and horizontally while gathering business requirements, while developing data marts. So he says that don't look at that business process only. You look around both horizontally and as well as vertically. So let me explain what we mean by this particular statement. So vertical span or looking vertically means what? So don't just rely on the business data analyst to determine requirements, and inputs from senior managers and senior people in the organization about their vision, objectives and challenges are critical. And ignoring this vertical span might cause failure in understanding the organization's directions and likely future trends. So it is very important that even if you are looking at a particular business process or a particular department, it is you must go and talk to people at the higher levels of management to understand what they want to do in the future, and try to incorporate that as much as you can into the data mart. And the horizontal span basically look horizontally across the departments before designing the data warehouse. So critical in establishing the enterprise view. So don't be kind of blind to the requirements of the other departments or related departments in the organization. Okay, so because otherwise there can be a lot of inconsistency that can creep in the different data marts that you design. Challenging to do if one particular department is funding. This should be is, right? Is funding the project. So say suppose I'm saying that okay, you build a data mart for sales. So now you'll say that okay, I'll not be interacting with the inventory because I am funding this particular project. So you better focus only on the sales process. Ignoring horizontal span will create isolated department-centric databases that are inconsistent and can't be integrated. So this is very important. So inconsistencies in the data marts can be there, and it will be difficult to integrate these data marts. Complete coverage in a large organization is difficult. So what Kimball suggests is that have one representative from each department interacting with the who will interact with the core development team, and this can be of great help in designing data marts, which can later be easily integrated. So Kimball proposed a new approach, and I'm going to talk about that. So plan and define requirements at the corporate level. So that's the first thing. So that's the horizontal part. Create surrounding architecture for a complete warehouse. So basically, when I say surrounding architecture, that means I should have a plan for integrating different data marts, and conform and standardize the data content, because in different departments the product codes could be different, or anything could be different. So you need to conform that, or you need to make sure that the data content is standardized and conformed, and implement the data warehouse as a series of supermarts. So this is the new thing, new concept that was given by Kimball. So I'll talk about what are supermarts one at a time. Okay. So let us talk about supermarts. A totally monolithic approach versus totally stir-pipe approach. So monolithic means with one big system that you're trying to develop, right? And totally stir-pipe means you are creating very small pieces, and then you're trying to integrate them, right? So that is called the stir-pipe approach. So as you know that in computing specifically, you'll see that monolithic systems like supercomputers, people are not preferring that because they are very expensive. Instead, what they are doing is they are trying to generate equivalent computing power by connecting small machines into a cluster, and then using them as a supercomputer, or as a system which are quite powerful in terms of computing. So let us see this part now. So let me go to the next point. A step-by-step approach for building an enterprise data warehouse from granular data. So this is another important aspect of this. So a supermart is nothing but a data mart. A supermart is a data mart that has been carefully built with a disciplined architectural framework. So that's the basic difference. And the second difference is about the granularity. So it is a complete subset of the data warehouse. So what now I'm trying to tell you is that you have a data warehouse which has a granularity, and you have a supermart which has the same granularity. Okay, so so now if I have all my supermarts at the same granularity at the data warehouse, then integration becomes easier. So, and once they have the same granularity, then I can say that some data has been taken directly from the data warehouses and put in the supermarts, or taken from the supermarts and put it in the data warehouse. So they are kind of, a supermart can be considered as a subset of the data warehouse. And this is what I'm saying. Most granular data that can possibly be collected, sorry for the typo. So possibly be collected and stored. So so this is the main difference between a supermart and a data mart. So supermart would have an integrating framework in place. And second is it will be based on the most granular data that is available. So these are the two differences between data marts and supermarts. So Kimball suggests that instead of building data marts, you build supermarts, and conform dimensions and standardized fact definitions. So you have to also conform all dimensions, and you need to standardize all facts. So pilot projects, so risk versus reward. So this again, let me clear this annotation. So start with the pilot implementation as the first rollout for the data warehouse. And pilot projects have the advantage of being small and manageable and provide organization with a proof of concept. So here is a kind of comparison I'm trying to do with using the concept of risk and reward. So functional scope of a pilot project should be determined based on the degree of risk enterprise is willing to take and the potential for leveraging the pilot project. So here we are not building a throwaway prototype. So what this means is that this prototype that we are building using the pilot project is ultimately going to be a part of the enterprise data warehouse. So pilot warehouse must have actual value to the enterprise. I mean, we call it warehouse or a mart, doesn't matter right now because it's a pilot thing. So it could be a combination, or it could be couple of data marts that you are building or supermarts that you are building. So here, let me again clear these annotations. Okay. So pilot projects, risk versus reward. So this is a very standard way of looking at things. So if you look at the x-axis, we have the reward, right, and on the y-axis you have the risk. So I want to maximize the reward and minimize the risk. So low risk, high reward. So this is the most ideal kind of setting that I would want to be in. Okay, whereas I would definitely not want to be. Sorry, I'll use some other color. And let me clear the annotations and then I'll use some other color. Okay, so I would definitely want to be in this quadrant because the risk is low but the rewards are high. Okay, at the same time I don't want to be in the high risk low reward quadrant, right? Some people would be willing to be here in the high risk high reward kind of category, and some people may just want to say that okay, low risk but the reward is also low, but I'm fine with this. But definitely you don't want to be in this high risk low reward quadrant. So this is what it is. So if you are trying to build a pilot project, right, so you could be in a low risk low reward kind of setup. Okay, but these Inmon's approach, right, so if you typically look at that, so there's a high risk, it could be high risk high reward kind of a situation, and I put a single tick there. So that means some people may want to use this kind of an approach, whereas I put two ticks in the purple box, which is low risk high reward. Okay, so if I were to ask, if I were to put Inmon and superimpose Inmon's approach and Kimball's approach onto this on these quadrants, I would probably put Inmon here. Okay, and I'll put Kimball in this box. Okay. Right, because since you are building EDW here directly, okay, so definitely the rewards are going to be high. Okay, and but the risk is high because it's a long drawn project and requires lots of resources. Now if I come to this quadrant here, say low risk and low reward, you can see I put a single tick here. So this is just like, okay, I don't want to build a complete data warehouse. I am happy with a couple of data marts, okay, or supermarts, whatever you may want to call them. So that would fall under this category. So I hope this concept of risk versus reward is clear in context of data marts, supermarts, and data warehouse. Okay. So let me just try to summarize the debate between Kimball and Inmon, and then move on to operational data stores. So there is no right or wrong between these two ideas, and these two ideas means Kimball and Inmon's, as they represent different data warehousing philosophies. In reality, the data warehouse in most enterprises are closer to Ralph Kimball's idea, and that is mainly because most data warehouse started out as a departmental effort, and they were like people started off by building data marts. Only when more data marts are built, later do they evolve into a data warehouse. And there have been like since Inmon also proposes advocates the use of ER diagrams for building data warehouses, right? So many there are many instances of projects which have failed because of the overly complex ER diagrams that they have to work with. So Kimball's approach is more practical. That's what I would say. But if you look at the rigor and the backing in terms of standard backing in terms of ER diagrams, so there is a strong mathematical background to all this. So technically, Inmon's approach is more correct, whereas Kimball's approach is more practical. And one of the major criticisms of Kimball's approach is that all the situations are not kind of envisaged, and every day we come across new and new modeling problems because of the dimensional modeling that we are using. So, and what happens in such a situation is that whenever a new problem is posed, so Kimball and his group kind of try to solve that problem, right? And when they try to do that, many a times the simple star schema that we talked about gets distorted, and that leads to a series of problems. So I'll be talking about those as well, okay, in the later part of the course, and how do we actually handle those problems created by distortions. So all those things I'll be talking about when we do the module on advanced dimensional modeling. So let me now so this is a dependent data mart. So dependent data mart is, so this is basically the Inmon's approach. So you can see that these are my source systems, and I do an ETL or ETT. ETL and ETT are used interchangeably. ETL stands for extract, transformation, load, and ETT stands for extract, transformation, and transfer. So from the source systems, I apply ETT or ETL and put it in the data warehouse, okay, and then from the data warehouse I have to again do some kind of extraction, okay, to pull out data that is specific to a business process or a department, and then I do that and I put these data marts, okay. So this is this is what is Kimball's approach, Inmon's approach. So now let me move to the next slide. Yeah, so clear. So here you can see, so these are independent data marts. Independent because they are directly drawn from the source systems. So then we have again ETT1, and then again once the data is in the data marts, now I integrate them into a data warehouse. So that's the difference. So and these are some of the references that I've kept, so you can have a look at these references, mostly from the textbook and some of the reference books. Now let me come to ODS. That's the second important topic for today. So an ODS, or the operational data store, is a type of database often used as an interim area for a data warehouse. So it's kind of sits between the source systems. So kind of sits between the data warehouse and the source systems. ODS is highly volatile. Like if you remember the characteristics of a data warehouse, so data warehouse is not volatile. That is one of the characteristics of a data warehouse. Whereas ODS is highly volatile, and ODS is designed to quickly perform relatively simple queries on a small amount of data, such as finding the status of a customer order. So if you are familiar with the concept of a dashboard, okay, so this concept of dashboard is similar to that of ODS. So you try to monitor the health of the organization through this ODS. So you want to keep track of what things are happening, and suppose status of a customer order is still saying that it is pending, so you try to figure out why it is pending, and you try to make sure that it is delivered as quickly as possible, or it is shipped as quickly as possible. Okay. So an ODS is similar to your short-term memory in that it stores only recent information. So there is no history that is available in the ODS. It is always current valued, and it contains only the current data. In comparison, the data warehouse is more like long-term memory in that it stores relatively permanent information. So data warehouses typically keep 5 to 10 years of data. That is very common. Okay, so these are some of the kind of differences that I'm trying to highlight, and by doing that I'm trying to define this ODS. So this kindly look at this particular picture, and it is taken from Inmon's article, one of the Inmon's article, and you have the architectural positioning of the data warehouse or operational data store, which I told you already. So you can see here, so these are your source systems on the left hand side, and you do perform what is called as, so you have these batch programs, and which I typically call as ETL, and then some of the data from the source systems goes directly into the data warehouse, and some goes through the ODS. So that's what ODS sits between the source systems and the data warehouse. Here's another view of the same thing. Okay, so these are applications or source systems, so operational, and data warehouse, as you know, so there is a distinction or there's a kind of a boundary between operational systems and what they can do, what they are optimized for, and decision support systems also in terms of what they can do and what kind of data they contain. So what we do is, so we collect information or data from different sources and put it in the ODS here, and which is subject oriented, like in the case of a data warehouse, which is also integrated, right? But in a data warehouse, data is not volatile, so here it is volatile. So the ticks indicate the similarities, and the crosses indicate the dissimilarities. Current valued, ODS is current values, whereas data warehouse need not be, and detailed, so that is also not necessary in a data warehouse environment. But you can see that there are two characteristics of an ODS that are same as that of a data warehouse. That is, subject orientation is same and the integration part is same. Okay. So again, taken from one of the articles by Inmon on ODS. So in figure 1, ODS is seen by an architectural is seen to be an architectural structure that is fed by IT, integration and transformation programs, basically ETL. These IT programs can be the same programs as the ones that feed the data warehouse, or they can be separate programs. The ODS in turn feeds to the data warehouse. But you'll see that there are certain kinds of ODSs which take data from the data warehouse. So according to Inmon, an ODS is subject-oriented, integrated, volatile, current-valued data store designed to serve operational users. So that's the difference. So here, data warehouses are for strategic users, as they do high-performance integrated processing. In the early 1990s, the original ODS systems were developed as a reporting tool for administrative purposes. So it is basically administrative, or you can say operational purposes. So that was the how this concept of ODS evolved, and the closest thing that I see in the present environment is a kind of a dashboard. Subject oriented. So this, I think I have already explained to you all these points, so I'll skip through this. And now let me come to what is called as the classification of ODS. And there are basically 4 kinds of ODS that we need to learn about. So class 1. So you can see that refresh cycle is real time. That means from the source systems to the ODS. So that refresh cycle is real time. That means as and when the data is generated in the source systems, it is fed into the warehouse or into the ODS. And the amount of transformation that you do is very low due to because you cannot because it is done real time, so you do not have enough time to do too many transformations. Class 2. So these classifications are based on 2 aspects. One is the refresh cycle, like how much latency is allowed, and second is based on how much transformation you want to carry out. Okay, so if you have more time, definitely you can carry out more transformations. So refresh cycle is half to 1 hour. So it is kind of store and forward. So you store it in the operational systems and then do some processing and forward it into the ODS. And degree of transformation is medium. Class 3, refresh cycle is daily. That is, you have enough time. So you get almost like 24 hours. And it is done using what is called as batch processing. And degree of transformation is quite high. And class 4 is totally different. I mean, it is quite different from the other 3 classes of operational data stores. So refresh cycle is ad hoc and often involving pre-processed value-added information from our data warehouse, and degree of transformation is highest. So one of the things that we typically do, let me give you an example of class 4. So customer profiling. So customer profiling is typically done in this class 4 ODS. Okay, so more on this. Okay, let me clear this. So ODS is also referred to as a generation 1 data warehouse. So first generation, because it has got some characteristics of the current generation data warehouse, and separate systems that sits between source and data warehouse, source systems and data warehouse. There is also used the hot extract used for answering narrow range of urgent operational queries like was the order shipped or was the payment made. And ODS is particularly useful when ETL process of the main data warehouse delayed the availability of data and only aggregated data is available. So ODS has the same granularity as the source system, whereas a data warehouse can have a different coarser granularity than the ODS and the source systems. So typically in a data warehousing system, ETL is the major bottleneck. So if ETL is kind of delaying the availability of data, so you can refer to the ODS. So ODS plays a dual role. It serves as a source of data for the data warehouse and supports, and also it allows for querying and supports lower latency reporting through creation of a distinct architectural construct and application separate from data warehouse. And since it has got some characteristics of the operational systems and some characteristics of a data warehouse system, so we call it half operational and half distant support. And a place where data was integrated and fed to a downstream data warehouse, and some say that it is an extension of the data warehouse ETL layer. So it is basically your take where you want to position or how you want to position an ODS. And ODS has been absorbed by the data warehouse. So there are many situations where data warehouses bring or try to get data from the source systems as quickly as possible. So we call them real-time data warehouses or near real-time data warehouses. So real-time techniques allow the data warehouse to be always be completely current with the source systems. And data warehouses have over the years become far more operational than in the past. And footprints of conventional data warehouses and operational data stores now overlap so completely that it is not fruitful to make a distinction between the kinds of systems. So the bottom line here is that if you already have an ODS, then it can play, or then you should use it effectively to build your data warehouse. But if the ODS is not present and your ultimate objective is to build a data warehouse, then you don't worry about the ODS. So that's the bottom line. And this I've already told you, like classification in terms of urgency. So so this also I've covered. So this is some more details I've put here. And so class 4, I just wanted to talk a little bit more about class 4 and updates into the ODS from the data warehouse. So this is different in many respects because it draws data from the data warehouse. And data in the data warehouse is analyzed and periodically placed in the ODS. For example, as I told you, we talk about profile data, and I want to do a complete profiling of my customers, right? So that processing I do in the data warehouse, and then once I'm ready with that, I put this data in the ODS, class 4 ODS. And this is another way of visualizing this. So you can see these are source systems on the left and nightly batch pulls into an ODS, and then there's an operational reporting engine. Okay, so some kind of queries can be answered directly through this, and then from here I again do a batch process to load the data warehouse, and now these data marts draw their way from or draw their data from the data warehouses, and then you can apply different kinds of tools, end user tools to analyze the data on the data mart that is there in the data marts or in the data warehouses. So another common thing between Kimball and Inmon is that data marts are present in both the paradigms, right? So that is common. So ODS and real-time data warehousing. So there's a very close connection between the two. And as I told you, class 1 ODS is typically used in RT real-time data warehousing because of its low latency and low levels of transformations that are carried out. So that I've explained already. So right now in this module we'll not be talking about real-time data warehousing. That will come in a later module. So the idea behind introducing ODS is that it's an important architectural component of a data warehousing system. And later, when we talk about real-time data warehousing, we'll again refer to ODS. So with this, I end today's session. And in the next session, I'm going to give you some brief idea about the other components like the data staging area, the presentation servers, and of course about OLAP, right? So these are the few things that will be discussed in the next session. Thank you.